This is the second video regarding concrete slabs, and it deals with one-way slabs. This video explains for slabs how to use partial factor method for loads, and it is basically the same as explained in the playlist Concrete Beams 2022. We will now talk first about span and geometry. For slabs is the same as for beams. The effective system length is equal to the net span Ln plus two elements A1 and A2, A1 on the one side and A2 on the other side. And A1 and A2 are defined by the minimum of half the depth of the slab or half the depth of the support. It's not the total support depth, but the support depth that is used. When you have a continuous member, then it's the same again. It's the minimum of half the depth of the slab or half the depth of the support. When it is fully restrained, then you will see again the same formula, half the depth and half the support depth. Of course, when you have a bearing, then the problem, or it's not a problem, but when you have a bearing, then the effective span of the slab will be defined by the center line through the bearing. For a cantilever, it's again the same formula. For slabs, when you have a column support or a continuous support, you can subtract from the maximum bending moment, that's the green one, that's the maximum bending moment, you can subtract an amount, which is delta M. And this amount that you can subtract is the support force, FED, and multiplied by the width of the support divided by 8. We will give a summary of the loads, and it's the same as the video 2 of the playlist Concrete Beams 2022. If you have seen this video, then you can easily skip this part and go over to part D. For loads on slabs, they are divided in different categories, A, B, C, and D, and so on. And category A is for areas for domestic and residential activities. And then you see if it's a floor, then it's 2 kilonewton per square meter as mobile load. Stairs, it's 3, and balconies, it's 4 kilonewton per square meter. Category B is for office areas, and then you talk about a mobile load of 3 kilonewton per square meter. Category C is the areas where people may congregate, and then you got C1 to C5, and you see it's areas with tables, fixed seats, without obstacles, physical activities, and large crowds. And you see here the applied mobile load. It is considered as the characteristic value of the mobile load. Then we have category D, which are shopping areas. You have general retail and department stores, but it's the same live load. E is storage and industrial goods of industrial use. You have then accumulation of goods and industrial use, and then you have 7.5 and 5 kilonewton per square meter. Of course, if you know what kind of goods are going to be stored on the slab, then you can use the real load on the slab instead of those general characteristic values of loads. Then you have F, category F, which is for traffic and parking in buildings. It's not for traffic on bridges, it's only for traffic and parking in buildings. when it's smaller than 30 kilonewton, the traffic smaller than 3 ton, then you talk about 2.5 kilonewton per square meter, which is typical for parkings. And when you have traffic for larger than 3 ton, like fire brigade and things like that, then you have 5 kilonewton per square meter. Category H is for roofs, non-accessible and accessible. Non-accessible is 0.8 kilonewton per square meter, and accessible, then it depends on the use of the roof. And then you have also special cases like helicopters, plants, trees, and things like that. Then that have to be decided case by case. A very simple thumb of rule or method to recollect those figures. It is when you have this is now a house, and this is the cellar, and this is the living room. Well, in a house, the living room is 2 kilonewton per square meter. It's 200 kilogram per square meter. If you go to the office, for instance, this office in the cellar, it's 3 kilonewton per square meter. Then you take the stairs, and it's 3 kilonewton per square meter. You go to the balcony, it's 4 kilonewtons per square meter. And from the balcony, you can look at football, and then in a stadium, you got 5 kilonewton per square meter. So with this, you can easily remember the life loads the minimum life loads that has to be used for the calculation of concrete slabs. Just remember 2 kilonewton per square meter. That's also for a bedroom. This means it's only half a meter of paper. So if you stack up paper 1 meter high, you already double the load that you are allowed to. So be very careful with stacking paper in your room. The same happens with water. If you have a leakage, 20 centimeters of water, it's enough. And then you have used all your life load where it is designed for. So take care if you use a waterbed, because a waterbed has 30 centimeters of water. So not every floor can support a waterbed. Don't forget that. Then we have the combination value of a variable action. It is a value that takes into account the probability that two mobile loads happens at the same time. Then you have the frequent value of a variable action. This is a combination with a frequency of a week. Let's put it this way. And then the quasi-permanent value of a variable action, it is a value determined so that total period of time for which it will be exceeded is a large fraction of the reference period. So that means it's almost always there. All those factors, Psi0, Psi1, and Psi2, those factors are tabled and in Eurocode 1, of Eurocode 0, sorry. And then you see again, depending on the category of load that we have just seen, we have those different factors, Psi0, 1, and 2. Special attention is drawn to 0.7, 0.5, and 0.3. In most common cases for a normal building, you will use 0.7, 0.5, 0.3. If you remember those figures, then you can very quickly make your load combinations. Special attention to snow loads. In Belgium, you will see that Psi1 and Psi2 is 0 for snow loads. So it means that if you have a life load different from a snow load, then this life load must not be combined with snow loads. You can have as a first important or the first order mobile load can be a snow load, and this one you have to combine with the other loads, but not vice versa. Now, let's look at different limit states. It's just a summary to remind us of all the different limit states that are existing. You have the ultimate limit state, which gives us a fundamental combination, ULSP, the transient combination, ULST, and the accidental combination, ULSA. In principle, the difference between ULSP and ULST, there is no difference in the ponderation coefficients. It is only for the SLS serviceability limit state that there will be a difference. Then we look at the serviceability limit state. You have the characteristic serviceability limit state, we have the frequent, and we have the quasi-permanent. It's denoted by SLS K, F, and Q. Of course, there are some other limit states, which is fatigue and seisme, but we will not handle this in this course. Now, in the ultimate limit state, ULS, then we have to make some combinations. And the plus sign here means that you have to combine it with. The first is the permanent loads. The second is the pre-stressing load. Then you have the first variable load and you combined it with the combination values of all the other live loads. That's a combination rule. And you have to maximize and minimize this combination rule. In ULST, the transient combination, you see it's exactly the same formula. There's no difference. And then for the accidental combination, you also have a combination rule. And to be complete for the serviceability limit state, we have also this type of rules. And you see here the psi0, psi1, psi2, and you see the use of it. You see psi0, which is the combination factor for the simultaneity of two loads, mobile loads acting on the same time. You see that's the first rule in characteristic combination. And you see that the psi1 and the psi2 is made for the frequent combination. And the psi2 is typical for the quasi-permanent combination, because the psi2 is the smallest. This is 0.7, 0.5, and 0.3. The ponderation coefficients, the gamma coefficients, you will see here for each ultimate limit state and serviceability limit state, you will see the different ponderation coefficients. G means for the permanent loads, Q for the mobile loads, and P for the pre-stressing. Now we'll tell you something about the acting forces, bending moment, normal force, and shear force. One-way slabs are calculated as beams, but with a width of 1 meter. So that makes it easy. So a one-way slab, you just act as if it is a beam with 1 meter width. I have made a little sketch. If you see, look at this slab supported by two beams. You take 1 meter width and you calculate this as a beam. Bending moments and shear forces are expressed per meter width of the slab. So don't forget that. So if the bending moment is, for instance, 50 kilonewton meter, it is in fact always kilonewton meter per meter. But in practice, we don't say explicitly per meter. To make a distinction between bending moments for beams and bending moments for slabs, we use a small letter m. So you have the big letter MSD for beams and the small letter MSD is for slabs. The same happens for the shear force. Now, when a slab is supported, for instance, by brickwork that's going with different levels, Then you will always have a hogging moment. It's an accidental hogging moment because of this semi-clamped support. It's not hinged. It's a little bit it's hinged, but it has some resistance due to the eccentricity of the reactions. So when you calculate the one-way slab, you should always include an hogging moment of at least 1/4 of one. You should at least hogging moment of at least 1/4 of the sagging bending moment, the bending moment in the field. And this over a distance of 1/5 of the span.